and Steve. Hi, I'm Shaki. I'm a product manager with S3, and I'm excited to talk to you about managing Amazon S3 security at scale. So let's dive into the session. So increasingly, customers are transitioning all their applications to the cloud, while many are just starting ground up in the cloud. As a result of this shift, more and more customer workloads are moving to Amazon S3. Customers choose Amazon S3 for a lot of different reasons. For some, it is about the high availability, high throughput, the scale they can reach with Amazon S3, the 11 nines of durability, the ability to store data across multiple regions with cross-region replication. For some, it's the wide range of cost optimization capabilities we provide to store millions and billions of objects within S3. And for some customers, it's about the security and management features that we offer, giving you the ability to control access at the object, bucket, and account level. And in this session today, we will use a case-based approach to learn about these tools and capabilities that will help you enforce a simple security at scale. So let's look at the first scenario. Let's say you are the CISO of your organization and are responsible for meeting your compliance and security mandate. Your compliance guidelines require that all objects are encrypted and no objects are available publicly. How do you achieve this? We will look into two S3 features today, S3 block public access and S3 default encryption. Let's start with block public access. To guard against accidental public access, Amazon S3 block public access is a feature that applies a blanket protection against public access. S3 buckets are private by default, and this feature can be set at the bucket level or at the account level to guard you against public access. It provides protection against permissions from ACL, bucket policy, or both. So let's go through an example of how block public access help you secure your buckets. So here we can see in the S3 console there are 9 buckets, and in the access column you can see the status of those buckets. So there are 2 buckets that have public access enabled right now. So now once you turn on the block public access at the account level, this setting gives you the overarching protection across all of your buckets and overrides your individual bucket level setting. So now after I turn on block public access at the account level, you can see that all of the buckets are protected and the 2 buckets that were flagged are now secured and are not publicly accessible. So that was about managing public access. I would like to share 3 key best practices around that. First, you should use Access Analyzer to understand how your bucket is being shared across different AWS users and take appropriate action. Second, you should try and keep all of your public data in one AWS account so that you can turn on block public access at the account level everywhere else. And lastly, I would strongly suggest using bucket policies as your central place to manage access and disable ACLs everywhere. So now let's move on to Amazon S3 encryption. We want to talk about default encryption feature in detail, but before that, I'll talk about how Amazon S3 provides you options to enable encryption. So here is a simple network diagram. You have the client and the bucket. And Amazon S3 would give you 3 ways to enable encryption. The first is client-side encryption. In this case, you manage the encryption before uploading your data to Amazon S3. So that means you manage the encryption keys and the system that encrypts your data before uploading to S3. We have AWS encryption SDKs available to facilitate this process. Second is encryption in transit. You can use encryption in transit by enforcing HTTPS and TLS as your data moves from your applications to S3 and needs to be protected over wire. And last but not the least, we have encryption at rest, where your data can be protected within Amazon S3 while it is stored there using encryption keys. And there are 3 ways to do that. SSE S3, which is the Amazon S3 managed keys, where you totally outsource the encryption process to us. Second is SSE KMS, where you're using AWS's key management service to control your encryption keys and their access across wide range of AWS services, including S3. And third is SSEC, which is the customer provided keys option, where you provide us the keys when you are uploading and downloading data from S3. So that was about encryption options within S3, and now we'll talk about default encryption. With default encryption, you have the ability to set up S3 buckets where data is automatically encrypted by default. It is a one-time bucket level setting where you define your encryption key, whether S3 managed key or a customer managed key that we discussed in the last slide, and all your subsequent uploads to your bucket are automatically encrypted. We also launched S3 bucket keys a year ago, and that will help you reduce your KMS cost by up to 99%. Now let's move on to the second scenario. Let's say your organization is hosting tens and thousands of S3 buckets that are spread across multiple AWS accounts. And these buckets often have shared data that is accessed by multiple users that are spread across these accounts. And now you're part of the security team and are looking for ways to simplify your policy management for cross-account users across the organization. How do you achieve this? Let's review S3 features that will help you simplify security management at scale. First, let's look at simplifying your ownership and permissions in S3. In S3, you have three options. You have the IAM policy, the bucket policy, and ACLs. Let's look at each one of them. So an IAM policy is defined within Identity and Access Management Service within AWS, and it defines what actions can this IAM user perform. It has three mandatory elements: effect, action, and resource. And in this specific example on the screen, we have an IAM policy that allows an IAM user to read and write objects to a bucket called sample bucket PyDay. As you can see, there are three actions. The first is the effect, in which case you are allowing the policy to take effect. And in the action, you are allowing the S3 put object and the S3 get object get access to the resource. And the resource in this specific case is the S3 bucket called the sample bucket PyDay. So that's how you define the IAM policy. Now, who gets to apply these IAM policies? If you are the IAM administrator for your AWS account, you define the IAM policy and attach it to an IAM user or IAM role within your account. You can further allow an IAM user to assume an IAM role. With role assumption, the IAM user inherits the permission of that IAM role. Next is bucket policy. A bucket policy defines who can access my bucket and what actions can that user perform. It is very similar to an IAM policy that we just saw that uses the JSON format. But what it requires is an additional principal statement that states who the policy covers. So here in this example, the bucket policy allows AWS account ID 12 ones to read and write objects to the bucket called sample bucket PyDay. Last but not the least is access control list. It predates IAM and is the way to provide object or bucket level access to your resources. So that was about the mechanisms for accessing data in S3. In S3, to recap, there are multiple ways to grant access to your data. You can use the IAM policies, which define what resources the IAM roles in your account can access. Then there is bucket policy, where you can grant or deny permission to different users using bucket policy. And this is usually how you grant an external AWS account access. And lastly, there is access control list, which predates IAM and is an atomic attribute for each bucket and object to grant access. So let's talk about cross-account writes. So cross-account write is a common situation for customers with multiple AWS accounts. So let's use an example to show how cross-account write is done today. Let's say you own the account A and have a bucket that serves as a data lake. Account B wants to write data to your bucket. Now there are three complexities there. Account B will need to give you permission to read via an ACL for data written by account B. And whenever account B writes data to your bucket, objects are owned by account B. And third, because you don't own the objects, you cannot use bucket policy to give other accounts access, and you have to do that through an ACL. This can present challenges such as enforcing bucket policy to objects that are owned by the bucket owner in account A. And we think that using a bucket policy is a modern best practice approach to sharing your data with other AWS users. You use bucket policies to share data with other customers and create a security perimeter to deny access. So in this example, objects that are written by the external account B, are owned by that account, and the objects that are written by account A in the bucket continue to be owned by account A. And the result is that the bucket owner cannot further share that object written by account B via a bucket policy. And we wanted to help customers in that use case and have added the capability to S3 object ownership, a bucket setting that you can apply. And this new feature that we launched last year is the right answer for nearly all our customers today. It does two things. First, it makes sure that ACLs are disabled. Second, it ensures that the bucket owner will own every object in your bucket. And it means that bucket policies will be the only way of sharing data, and ACLs are completely out of the picture. So in that example that we saw before, now when you enable bucket ownership setting, you will see that objects that were written by account A continue to be owned by account A, but now that the objects that are written by account B will be owned by account A. And what that means is that when you apply a bucket policy, that can be uniformly applied to objects that were written by account A as well as account B. So compared to before, you wouldn't have to deal with an ACL. For example, when account B writes to your bucket, the write doesn't need to specify an ACL. You own all the objects, and you can now use bucket policies to control access for those objects. So it's a bucket level setting, as I said before, and we're adding this as the third option to the S3 object ownership. It's called bucket owner enforced. And you can apply it to your existing bucket or to a new bucket. And if you want to turn it off, you can do that anytime, and your previous ACLs will be restored. Next is access points. As you grow your data sets and add multiple shared data sets to your buckets with multiple client access, your bucket policies get more complex. And Amazon S3 Access Points helps you simplify your access management for buckets that contain shared data set. As you can see in the illustration here, access points help you divide access to your bucket into multiple groups of users, each with their own access policies in the same bucket. For instance, you can divide cross-account users into 3 groups: finance, sales, and dev. And each group will read data from a designated access point that has its own access point policy. And last summer, we launched S3 Access Point Alias that makes accessing your access point from other clients even more easier. With Access Point Alias, each access point will receive its own unique bucket-based alias that can be used to replace the bucket name URI for data access. And this means you can use these access point alias for all of your S3 API requests to talk to services like EMR, and they will automatically connect to the access point without requiring any code changes. Next is policy validation with Access Analyzer, and this feature guides you to author and validate secure and functional policies. It comes with more than 100 policy checks, and you can use these checks while you are creating these new policies or to validate your existing policies. You can use this feature to confidently check that your policies provide intended access before they're attached to IAM principals or S3 buckets. And this saves you time and improves your security posture while simplifying permission management at scale. Policy validation, as I said before, is a feature that has more than 100 encoded validations based on AWS suggested policy writing best practices. It will analyze the policy to dynamically generate findings that help our customers identify issues during authoring of these policies. And findings can be categorized into errors, warnings, and suggestions based on their impact. Error findings are generated when a policy statement is non-functional. For example, it will generate an error when customers wrongly use S3 list buckets, which is an invalid action, instead of S3 list all my buckets, which is the correct action. Warnings are generated when a statement contains constructs that may make the policy susceptible to security risks. For example, the policy validation generates a warning when a policy construct allows an IAM principal to pass any role to any service, which may result in an escalation of privileges. And finally, suggestions are generated to recommend stylistic improvements to your policies that will not impact the access allowed by the policy. For example, it generates a suggestion to remove any redundant action, which will help you author a well-structured policy that remains within the policy size limits and are easy to understand and maintain. So like I said before, policy validation is a great feature that is turned on by default in JSON policy editor in both your IAM and S3 console. In IAM console, you can view findings generated by this feature when creating a managed or inline policy for your IAM principals, both roles or users. In the S3 console, you can view findings generated by the policy validation feature in the policy editor when you're creating a bucket or an access point policy. And this policy validation feature will dynamically generate and update your findings as you edit your policy. These findings will also guide you by providing you actionable steps to fix the issue in a policy statement, along with links to the AWS documentation to take the suggested action. So to wrap up, we looked at two cases today. In scenario 1, we looked at compliance management at scale and saw how you could use default encryption feature and block public access to enforce compliance at a click of a button. And then we saw how you could simplify your access management at scale using features like object ownership, access point, and IAM access analyzer. Thank you for joining my session and taking out time to learn more about how to manage your security at scale within S3. I will now open up for questions.
Thank you so much. Thank you so much, Shaki. It was great to hear about all of these security features that we offer our customers in S3. Now, for those of you watching who have I would say, a fairly typical use case for data in S3. They have data, it's part of their applications, it's part of their data lake, it's their configurations, it's their logs, all of these things that you can use in S3's virtually limitless scale. And someone watching this might be wondering, how do I take that data and secure it correctly? So if you had to break, there's a lot of features here. If you had to break down, how do I do this in a way that's right for most modern use cases in S3? What would you go and do with your data, with your buckets in S3, Shaki?
Yeah, that's a great question. And I think the answer to that is turn on block public access and disable ACLs for your buckets. We think that's the right answer for most of our customers. And that is the reason why you'll notice in the S3 console, when you go to create your own bucket, we have those options defaulted in the create bucket flow. So we think that these two features are the right answer for almost all our customers. When you want to make your data public, you really want to make it public, and you would want to store that in a separate AWS account. And we are in year 2022, and we think that customers are using bucket policies and IAM policies to enforce access management, and disabling your ACLs is almost the right answer for almost every use case.
That's right. Really, most of the times when you have data in S3, your intention is not to make it publicly accessible. So the most straightforward, and even if you're looking to use S3 to host website content, often you're going to be using a content delivery network, for example, AWS CloudFront, to put in front of it. And in all of those cases, you don't actually intend to make your data public. And as Shaki points out, when you're using our console to create a bucket, you'll notice that we've already selected for you as defaults, that you can opt out of, but as defaults to sort of nudge you to the right, what we think are the right answers, having ACLs disabled and block public access. So Shaki, since disabling ACLs is a pretty new feature in S3, one that we only launched a couple of months ago, but has been enjoying some strong adoption. So let's say I created an S3 bucket sometime over the last 16 years. I've got a few years, maybe a few buckets, maybe a little bit of data in that bucket, or maybe a lot of data in that bucket. Now, I know that my use case is modern. I'm using bucket policies to grant access to the data where I need to. And, well, I might be interested in disabling ACLs on these existing buckets. Can I do that? Or is this only a setting for brand new buckets?
Yeah, so this is a setting for both new and existing buckets. And yes, you can turn this option on for your existing buckets. It is a reversible option. We take a lot of care in making our features operationally safe here at Amazon S3, and we've taken the same approach with this feature as well. We would recommend just checking your bucket policies and making sure that it accounts for all the access, intended access for your external AWS accounts and users, and then you're good to go. Like I said before, we think that bucket policies is the modern and best practice approach to manage your data access centrally. So you just need to look at that, and you're good to go.
Okay, so tell me a little bit more about that. How do I make sure that you say that in order to be able to disable ACLs, of course, it still means that I can share my data, because there are many use cases in S3 that involve that, often controlled through this IAM policy that you saw Shaki mention in her talk. What kinds of things should I look for to know that I've already accounted for all of my use cases in a way that I can safely disable ACLs without, changing how my application sees S3 working?
Yeah. So you might want to. So you were using ACLs for a reason before, right? So for example.
Well, maybe, right?
Yeah.
Yeah.
And you want to make sure that the intended access that you wanted to provide through ACLs is now being accounted in your bucket policies. For example, read and write access to a certain user in an AWS account, that should just have your read access. Similarly, there's an object that maybe needs to be, public. So that means you might want to move that object to a different account where you are making sure that your public objects are being stored centrally in an AWS account. So you want to make sure that all of your intended access policies that were being run by the ACLs are now being accounted in that bucket policy.
Yeah, and I'll also add, since this, we're kind of celebrating the history of S3. Today, it's 16th birthday here on Pi Day. I'll also note that ACLs, this feature of S3, is really one of the original features of S3 when we launched it as storage in the cloud back in storage for the internet back in 2006. And this was sort of a model that was very much sort of after this kind of storage for the internet pattern. In fact, S3, it almost looked like a file system, because you had these object names, they had slashes in them, kind of made you think of directories, and directories make you think of file systems. And file systems make you think of access control lists, or ACLs. And it's actually been very interesting to watch the evolution of this. About 2011 is when we introduced identity and access management, all of these modern controls that Shaki has been telling us about. And this disable ACLs, or this object ownership kind of construct that we have in S3, it's really very much to provide this kind of smooth transition from this storage for the internet world of ACLs to this more kind of AWS-centric, not so much storage for the internet, but maybe storage for my enterprise, storage for my application, storage for my workloads, where the data is private, and you're really looking for this one sort of point of control for permissions to your data. So Shaki, maybe tell us a little bit about kind of why, Shaki said it a couple times. We'll say it a couple more times today. We really think that the ability to kind of disable ACLs and focus on your bucket policy is a great thing to do to keep your data straightforwardly secure. Shaki, can you tell us a little bit about why we are recommending that? What is so great about this feature?
Sure. Yeah. So customers have told us that they really like the fact that they have the flexibility to control access through multiple mechanisms in S3, but they would want to simplify that to one single place. And bucket policies help you manage that for a modern data lake, right? With ACLs, customers would often not be able to manage access at the object level, especially when you are hosting billions and trillions of objects within S3. So they want to be able to manage that access through a single bucket policy that governs access for all the objects within that bucket, and you can simply ensure that your management and governance for access runs through that single bucket policy and not through any ACLs at the object level that might override your bucket policy mandates. So that's why we wanted to give that option to our customers to centralize this access management through one single place, and we think that bucket policies would be the right answer for that.
Yeah, I absolutely agree. I mean, when you're trying to do actually a lot of the things we're going to talk about today, security and backup, one of the things you want to know is, did I do it right? Yep. And what Shaki's telling us here is that by focusing on bucket policy, it sort of shrinks the surface area that you need to look at to know that you did it right. Actually makes things, we've said a lot about policy, but it actually makes it much simpler and straightforward to audit these things at scale and figure out exactly whom you shared your data with, and made sure that it's all the entities that you wanted to share it with.
And I think making it straightforward and simple gives you confidence that
you
got it right.
Absolutely. Absolutely. And actually another set of tools that we heard about today that helps you be sure that you're going to get this right are the recent launches in IAM Access Analyzer and the policy validation that we talked about. So Shaki, tell us a little bit about that. What are the confidence features? Because S3 is deeply integrated with identity and access management, this cross AWS permission system. What are some of the tools that IAM Access Analyzer and the policy validator give you so that you have confidence that you've done security right in the cloud?
Yeah. So really excited about this feature. Customers would often tell us that they like the flexibility of being able to provide the intended access through the bucket policies or the access point policy, but they often wanted some kind of guide to tell them that they're moving along the right way, right? So that's why we decided to offer this feature to our customers, where when they are writing these policies, they will automatically get these notifications that would guide them whether they're writing the right policies. Like I said, these policies could be violating, say, your security privileges, in which case there'd be a warning. and are kind of like following the AWS best practices guidelines. You could also be, for example, exceeding your policy size limits. So these policy finding checks would suggest you to remove certain redundant actions from your policy so that you can keep it within limits and keep it structured for any new person to come and manage your central policy. And then since S3 has a lot of APIs, you can often write policies that are not intending the correct action. So for example, in the example that we saw in the slide, you could be saying list buckets when the actual word is list all my buckets. So this validation feature will flag that for you while you are authoring that policy and help you get to the right policy and a well-structured policy faster.
That's right. They help you. I find the policy validator very helpful in just catching sort of the common mistakes or sort of what I probably should have done instead. The Access Analyzer, of course, is a very helpful tool in translating my policy into English, telling me who actually has access to the bucket as a result of its sort of analysis of the policy that's been written. Now, of course, Shaki, it's Pi Day, and I have a very important question for you here.
The most important question.
The most important question. What is your favorite kind of pie?
I think apple cinnamon would be my favorite
Apple
pie
cinnamon.
because apple is my favorite fruit and cinnamon is my favorite tea. So I find the mixture, the combination really exciting, and apple cinnamon pie would be
So
my
are we talking crust on top or crumble on top, Shaki?
favorite. I would say crumble on top.
Crumble. I'm totally with you about that. Crumble
Is that a pie though, if it has crumble on top?
it is absolutely a pie if it has crumble on
Okay.
top.
Well, with that selection, that just pushes apple pie into the lead in the sweepstakes.
Excellent, excellent. Well, pie itself actually doesn't have very good security controls, tends to disappear very quickly if people aren't watching it very closely. It's actually quite a different matter from an S3 bucket. Well, thank you so much, Shaki. It was great to have you with us today. Okay, so that was our spot on our straightforward security controls in S3. And we're actually going to talk about next we're going to talk about another side of data protection in S3. Security is obviously a way of protecting your data. Security controls, making them accessible where they're supposed to be, making them not accessible where it's not supposed to be. But there's actually another side to data protection in AWS, and that's what we in S3, we call it durability. And I would say that if there are two things that all of us who work on S3 obsess over, it is security and durability. Now, durability is something, unlike security, durability might not be something that you as a user of cloud storage necessarily immediately think of, right? Because from the perspective of using S3, put data objects in the cloud, get data objects out of the cloud, but it actually takes a lot of work to make sure that the data objects, retrieve any object of any data of any size from anywhere at any time, right? And it needs to be the object that you put in there. Again, it sounds obvious, but there's actually a lot of deep thinking and innovation that have gone into durability at AWS. Now, I'll tell you, since I work on S3, a lot of the innovation that goes into durability, it's below the surface. It's stuff that actually, as a user of S3, you will never see all of the work that we have done into being sure that when you trust your data with us, it's the data that you put in, we hold on to it, and it will be there when you want to get it, potentially years and years down the road, right? Like you even heard about these archival storage classes before. They're precisely for these use cases where I'm going to put data into the S3 and Glacier, and I wanted to.